This tutorial introduces steel bracing tools in ideCAD Structural. It covers vertical brace modeling between beams and columns, roof-level bracing using the multiple brace tool, and the placement of individual braces for localized stability. Settings such as section selection, connection types, alignment, and effective length definitions are also explained. By the end, a complete bracing system can be modeled for wind and seismic resistance. Let's now move on to the steel brace command. I'll start by modeling vertical braces. From the Steel tab, I clicked on the Brace command. In the dialog that opens, you'll see three subcommands. The first is for vertical braces, the second is for multiple braces, mostly used in horizontal bracing, and the last one is for single braces. You can select a section from the drop-down list. For example, I chose CHS 88.9 by 5. I then clicked Settings on the far right. Starting with the General tab, the first field is the element name. You can rename it here. Next is the section group. As with columns and beams, you can either select from the list or click Load Section to access the section library. You can also assign a material. If you're using built-up sections like double or quadruple L or U shapes, you can activate the mirror option or rotate the orientation using the Rotate command. In the Appearance tab below, you can customize the display color and material, but we'll skip that for now. Under the Type tab, you'll see configuration options: single diagonal, X-type, inverted V, and V braces for concentrically braced frames. Below that are configurations for eccentrically braced systems. When you select one of these, the E parameter becomes available for entering the eccentric beam length. For example, 100 centimeters. You can right-click the input box to change units. I'm choosing an inverted V configuration for a concentrically braced system for now. Under Body Deformation, you can adjust clearances in the X and Y directions to avoid clashes. In the Side Selection tab, options are labeled as 1, 2, 3, meaning back, middle, and front of the beam respectively. If you want to input a custom value, you can activate the Custom option. I'll proceed with the current settings. I clicked OK and started modeling from the perspective view. I selected the first beam. See how the vertical brace was created. Let's enlarge the perspective view to make modeling easier. One shortcut: when you click the middle mouse button, the software remembers the last command and its settings, so you can repeat actions quickly. I did just that and continued placing more braces. In large projects, instead of placing braces one by one, you can use the clone or array commands to model them quickly. Now I'll demonstrate the multiple brace command, typically used in roof structures. I switched to the second story, selected the brace tool again, and chose the multiple brace option. Before modeling, I clicked Settings to change the type to X brace, which is more suitable for roof structures. After confirming the type, I selected the first and second beams and input the number of segments. For an 8-meter span, I chose 4 segments to satisfy LTB spacing requirements. I then checked the brace's properties. Remember, to adjust offsets, go to the Body Deformation tab. The software used the 0 point of the beam, which created a clash with the column. To avoid this, I edited the properties again and resolved the overlap. Doing this in advance speeds up later modeling using clone or mirror tools. I selected the roof braces and used the clone command with a filled-empty-filled spacing pattern. This also preserved the adjusted settings, eliminating clashes. Alternatively, you can repeat the process with the multiple brace tool by selecting beam pairs and entering brace counts multiple times. But I used mirror instead to save time. I selected all horizontal braces, placed the mirror axis at roof beam's intersection, and completed the brace placement. This ensured all braces were properly configured. Next, let's look at the single brace command. Why do we need it? For stability members placed between filled cells, we must model braces manually. I matched the section from the library and used Ctrl+click to snap to the node points. I'll also offset this stability brace. From the View tab, I created a new work plane on the beam surface. I selected the brace, right-clicked, and used the Move command to shift the element by 0.25 meters on the work plane. Then I exited the work plane by right-clicking on an empty area. The braces were mirrored symmetrically to the opposite frame bay. To copy this configuration to the other spans, I selected the upper brace and used clone again from column to column. The roof bracing on this side is now complete. Let's also add bracing for inclined beams. I repeated the brace command and used the multiple brace tool again. I selected the start and end beams and entered a brace count of 3 for the smaller span. To avoid clashes, I selected the brace group and used clone, snapping from one column node to the next. Bracing is now complete for both vertical and inclined regions. Finally, I'll place the remaining stability beams. As the Snap Perpendicular tool kept activating, I turned it off from the Drawing tab. I used the Columns node to place these last elements. Now the modeling process is complete. Thanks for watching. Don't forget to like, subscribe, and explore the knowledge base for more tips. See you in the following video.